So now we've described all of the motion that is happening with the object during each segment. Okay? Something else that you need to be able to do whenever you're looking at a v versus t graph such as this is find the velocity, instantaneous and average, find the displacement, find the distance, and find the speed, both instantaneous and average. Another thing that you should be able to calculate on this type of graph is the acceleration, which is the slope. Okay? So I have some sample questions here. And if you're in my actual physics class, you have this worksheet also. So you can actually go ahead and check your answers or redo this worksheet as extra practice. Okay? This is the first V versus T practice worksheet. So let's look at finding the displacement from 0 to 10. So from 0 to 10, we get to right here. This is 10 seconds. All right? So I need to add up with the direction, because displacement has direction. You need to add up all of number 1, all of number 2, and all of number 3. So I'm taking the negative 64, the negative 7, and the positive 7, and adding them together with direction. Displacement has direction. Okay? So once I find the displacement from 0 to 10, I can write my answer down. Okay? Negative 64 minus 7 plus 7 gives you a displacement of negative 64. Okay? Now, in order to determine if the object ends up to the left or the right of where it began, completely depends on one thing: the total displacement for the entire trip. Okay? It does not matter where this segment ends. It does not matter where this segment started. Position is not provided to you on an V versus T graph. So, the only way to determine if it becomes to the left or right of where it began is by finding the total displacement. Now, in this one, the total displacement ends up being positive 3 meters. So, if it is a positive total displacement, then the object ends up to the right. Okay? How do I find a velocity at one point? Well, that would be your instantaneous velocity. So this one's asking for the velocity at t equals 4. Find t equals 4. 1, 2, 3, 4. That's right here. So the velocity at t equals 4 is negative 8. What if I'm asking for average velocity? If I'm looking for the average velocity, then I'm going to use the displacement for that time. So the displacement from 0 to 10, which we already have, negative 64 meters, and divide that by the time that it took. So the time that it's actually asking for. So we do negative 64 divided by 10 seconds, because that's the time taken, and you get a negative 6.4 seconds. Please make sure you keep the direction. Velocity is a vector. All vectors have direction. Okay? If it would have been a positive number, then you would have put a plus sign in the front. Okay? Let's talk about instantaneous speed. It says find the speed at t equals 11. So I'm going to go to 11 and look for the speed. The velocity says it's positive 14. Instantaneous speed and instantaneous velocity will have the same magnitude, not direction, because speed does not have a direction. So the answer is just 14 meters per second. Okay, last question. The average speed from 0 to 10. When I'm talking about average speed, I need to use the distance from 0 to 10 and divide it by the seconds. Okay? So,